Alright, in this lesson we're going to go over writing linear functions, so kind of the opposite of what we were doing yesterday. So first example, we're going to write the equation from the graph. Okay, now usually I have us do it in slope-intercept form. Okay, this one even specifically says up here in slope-intercept form. So remember, that's y equals mx plus b. We need to know two things to write it in this form. We need to know the slope, and we need to know the y-intercept. So we come over to our graph over here. Easiest one to locate is the y-intercept. You'll see that where the graph is crossing the y-axis. So this is point 0, 1. Okay, now we only really care about the y-coordinate of that 1. That's going to be our b. Okay, then our slope, we just do a rise over run. Okay, so my rise, I'm going to go negative 1, 2, 3. Our run, 1, 2, 3, 4. So it looks like my slope is negative 3/4. My y-intercept is 1. So I can write out a pretty easy equation here. Y equals negative 3/4 x plus 1. Alright, example 2 has to do with finding slope. So we're going to need to use this slope formula, which I'm sure you've seen before. Okay, this is just another way of writing delta y over delta x, the change in y and the change in x. When you're finding change, you're finding the difference, minus. So, to do it from 2 points, we need to, A, find the slope. So I'm going to label these x1, y1, x2, y2. So subtract my y's, that's negative 5 minus 1. Subtract my x's, 2 minus negative 1. Okay, notice I did them in the same order. I did this first, followed by this, then this first, followed by that. You're going to get some double negatives that happen in this formula, since the formula has some minus signs in it. Remember, those turn into pluses. 2 negatives just added together is just another negative. Negative 6, 2 plus 1 is 3. Negative 6 over 3 is a negative 2. So there's our slope. Okay, a form we haven't talked about yet is called point slope form. It's y minus y1 equals m times x minus x1, where x1 and y1 are just any given point in a linear function. Okay, it doesn't have to be the y-intercept, it could just be any point. So this one's a little more flexible than slope-intercept form is. Alright, so notice it says write the equation in slope-intercept form. So one thing we can do is go through the point slope form and then just solve it out and get our slope-intercept. So that's what we're going to do first over here. So first thing I do is find my slope, rate of change. So on these I'm adding 1.5 each time, and on these I'm adding 4. So my slope is 1.5 divided by 4, which we don't want decimals and fractions in the same thing, so it's 3/8 if you just multiply them both by 2. 3/8. Okay, our y-intercept should be in the middle somewhere here, but we'll figure that out later. Okay, point slope form, we just need to pick a point. So I'm going to pick this one. It's the only one without decimals, and it looks easier to deal with than the 2 negatives. So that's going to be y minus y1, which is 1. Okay, this is my y1, this is my x1. Times m, 3/8 x minus 8, because that's my x1. Now I still need to get it in slope-intercept form, y equals mx plus b. So we just need to solve this out a little bit. I need to distribute my 3/8. So that gives me y minus 1 equals 3/8 x minus 3, because the 8's cancel. And then plus 1 to get y by itself gives me y equals 3/8 x minus 2. And there is my slope-intercept form. So there is a second method. You can go directly into slope-intercept form. Now the first part's the same, so we just do this m again. So we're not going to do it again since we already did it. So we know it's 3/8 now. But rather than go through this point slope form, which seems like a little bit of extra work to me, some people find it easier, that's why I show it to you. But instead, we can just say that this is an x and a y. And I have an x and a y up here in my slope-intercept form. So I'm just going to put these in for those letters, put in the m, and then I'm just going to solve it for b, which is what I don't know and I need to find. So that means it's going to be 1 equals 3/8 times 8 plus b. Okay, well 3/8 times 8, I know that 8's cancel, so that's 3 plus b equals 1. 3 from both sides, and I get -2 equals b. Plug everything back in the right spot. Y equals 3/8 x minus 2, and we have our slope-intercept form. And you'll see it matches what we got over here. So you can choose either method. I just want to show you a couple different ways, okay, just so you can see them, whichever one you feel more comfortable with. Alright, so this is another way to present the problem. They give us the slope, so we already have m. And then they tell us it goes through this point, but this point is not the y-intercept, unfortunately. That would make it really easy. So we have to use one of these methods. My favorite is method 2, so that's the way I do it most of the time. So this is, again, an x and a y. So that's 3 equals -5 times x plus b. Well, -5 times 1 is just -5, and I can get rid of that by adding 5. 3 plus 5 is 8. 8 is b, m is -5, y equals -5x plus 8. Alright, I'll do one more for y'all. And I'll do this one with point slope for those of you who are thinking about using that. Okay, this one just straight up gave us 2 points. What we just did on the last slide was find the slope using our slope formula. x1, y1, x2, y2. So that's going to be 5 minus -3 over 2 minus -2. A couple of double negatives in there that I know are going to turn into pluses. 5 plus 3 is 8, 2 plus 2 is 4, 8 over 4 is 2, and that's my m. Okay, I said I'd use point slope form. Now I labeled this x2, y2, but I'm going to use it now as my x1, y1 for this formula, for that and that. So y minus 5 equals 2 times x minus 2. Still need to get it in slope-intercept form, so we're going to distribute the 2. Y minus 5 equals 2x minus 4. Add 5 to both sides, and that gives me y equals 2x plus 1. Alright, last thing in this section is parallel lines. So parallel lines have the same slope. Perpendicular lines slopes are opposite reciprocals. Alright, so we're just going to write two different equations here. So we're going to write the equation of a line that is parallel to this line. So that means it has the same slope as this line. But our line goes through this point. So basically, once you find out what the slope is, you disregard everything else in this equation. These don't mean a thing to you anymore. The only thing that means anything is the slope. So our line is y equals 1.8x plus b. We don't know what our y-intercept is, just like the last page. So you can do point slope, or you can just plug these in. So again, this is an x, this is a y. 2 equals 1.8 times 5 plus b. Alright, 1.8 times 5 is 9. And subtract 9 from both sides. 2 minus 9 is negative 7. That's our b value. We know our slope already is 1.8, so y equals 1.8x minus 7. Okay, over here, perpendicular. So again, we know it's going to deal with the slope, and I'm going to disregard everything else in this equation. Okay, except the perpendicular is opposite reciprocals. Opposite means it has a different sign. So if it was negative, it's going to be positive, and if it was positive, it's going to be negative. So ours is going to be positive, and a reciprocal means you need to flip it over. So instead of 3 halves, it's going to be 2 over 3. So our slope is positive 2/3. Okay, and ours is going to go through this point. Again, we have an x and a y. Okay, I'll do this one in point slope for the point slope people. So y minus y1, so y minus negative 2 equals 2/3 times x minus x1, 9. Okay, so over here I'm going to distribute my 2/3. Okay, over here I have a double negative, so I'm going to rewrite that as y plus 2 equals 2/3 x. 2/3 times 9 is 18 over 3, which is 6. Then I'm going to subtract 2. Y equals 2/3 x minus 8.